This is 2-4. This lesson talks about parallel and perpendicular lines. So let's start talking about or looking at these three possible lines I have. One in red, one in blue, and one in green. And so if we had to graph these, and notice all of these are in y equals mx plus b. And so remember this is your y-intercept right there, and this is your slope. Remember, slope is defined as rise over 1. So we're going to start at -4 and then go up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1, and connect the dots. And that's the red line. The blue line, again, the y-intercept is right here at -1. So you're going to start right there at -1 on the y line. That's why it's called the y-intercept. Notice the slope is up 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And then we can connect the dots. Same thing with the green line. Here's the y-intercept at +2. And the slope, rise over 1, is up 3 over 1, up 3 over 1, up 3 over 1. And then we can connect the dots. So you notice all of these had something in common. And if you look at them, they all look like they're parallel. And so, what made them parallel? That's what we need to find out is, what in these three equations made them parallel. And just to double check this, on the calculator, if we substituted these into the calculator, we're going to get the same result. Y equals 3x minus 4 for the red, 3x minus 1 for the blue, and then 3x plus 2 for the green, and then push graph. And you're going to see the same thing as what I did, obviously a little bit neater. So, what was common with all these? If you notice all of these, all of them had the same slope. They all went up, rise 3 and run 1, rise 3, run 1. So if they have the same slope, then they are parallel lines. And so that comes to our definition. Parallel lines have the same slope, and they never intersect. And what that means is that they'll never touch each other. And by the way, I did make a little comment about the same plane. That's more of a geometry context, but the same plane, imagine two pieces of paper. So a plane is like a piece of paper. And so we're talking about on the same piece of paper. That's what that means. So, in geometry, we'll talk more about that, what that means, but that is part of the definition, so I just thought I'd include it. So basically here in algebra, parallel lines have the same slope. They never intersect. No matter if the line keeps going on forever and forever, they're, like that last example, it's still going to go up 3 over 1, up 3 over 1. They will never intersect. But again, parallel lines have the same slope. So when we look at our next example, here's write an equation of a line in slope-intercept form that passes through a certain point, 8, 9, and is parallel, again, parallel. Parallel lines have the same slope. So what we're trying to find is, here's an equation right here. There's an equation. And what we're trying to find is another equation that's parallel to this green line, to the, what I have boxed in. So we're trying to find an equation that's parallel to that, but it has to cross through the point 8, 9. So just to give you a visual learning, just a visual, if I graph this, I start at -2, and then I'm going to go up 3, 1, 2, 3 over 4. Up 3 over 4. And so this is the green line that we have here. And we're trying to find a red line that's parallel to this green line, but it has to go through 8, 9. So we're trying to find a line that goes through that, that's parallel. Well, what do we know about parallel lines? Well, parallel lines have the same slope, okay? So we know that the red line has the same slope as the green line because they're parallel. Parallel lines have the same slope. Well, the green line has rise 3, run 4. So it has, up 3 over 4, up 3 over 4. So the same thing with the line that we're going to have. We know that the red line is going to have slope 3/4 x, and then plus the y-intercept. We don't know what the y-intercept is. And there's two ways to find this. Let me just take you the algebraic way. We could do this on graph paper. Obviously, since I have a piece of graph paper out here, we could literally just do slope 3/4 and find out where it crosses the y line. We could do that, rise 3, run 4. We could do that, but we can also go down 3 over 4 to the left, and then down 3 over 4 to the left. And so we can find the y-intercept right there, but we don't have to use a piece of graph paper. So the way to do this without graph paper, use point slope form. Remember, point slope form is in my opinion, I've said this in class, is a very fast, superior way to do this. We know the slope is 3/4, and we know the point is 8, 9. So x minus 8 and y minus 9. And remember, it looks like a positive 8 up here, and it looks like a positive, it is a positive 8, it is a positive 9, but in the formula, it actually will look like a negative 8 and a negative 9 in point slope. Again, this is point slope form. Now, if the problem just said write an equation, we would be done. That's in point slope form, but it does say to write it in slope intercept form. If you notice this, it says write it in slope intercept. So what we're going to do is use the distributive property. And then add 9 to both sides. And so that's what we got anyway. We got positive 3. So this would actually cross this. And see, they're parallel. You can check it on a piece of graph paper, or you can pull out your calculator again and graph these two and find out where they cross at. You could do that if you wanted to. But we found, they are parallel because they have the same slope, 3/4, 3/4. They have the same slope, and they have different y-intercepts. So, they are parallel, and they cross, and it crosses through this. This line right here crosses through the point 8, 9. So let's look. That's parallel lines. Let's look at perpendicular lines. So perpendicular lines intersect at right angles. So, here's two different lines graphed, and notice this little square box that you've seen probably many times right here. This little square box. That little square box means that it hits at a 90-degree angle, a right angle. And so obviously, if that's a right angle, so is this, so is this, and so is this. They all meet. They intersect at 90 degrees. It's perfectly perpendicular. To be able to do that. So something I want you to notice about perpendicular lines, something about the slopes. Remember, parallel lines have the same slope. But let's look at perpendicular lines. So on perpendicular lines, if you notice the slope of, I'm rising 1, 2, let me back it up just a little bit. So I went up 2 and over 3. Went up 2 over 3. Went up 2 over 3. So this has slope 2/3. And then I want you to notice the slope of the other line. The other line has slope down 3 over 2. Down 3 over 2. Down 3 over 2. So this has negative 3/2 slope. So they are perpendicular, and notice the slopes of each other. Notice the slopes of each other. So what we can do is make a little rule for perpendicular lines. So perpendicular lines they do intersect at right angles, but their slopes are, and again, notice two things about them. One, you notice one of them is positive and the other one is negative? So one of them is a positive slope and the other one is negative. So that means they're opposite of each other. And you notice that one is 2/3 and the other one is 3/2. So they're also reciprocals of each other. So perpendicular lines have slopes that are opposite reciprocals, both things. So make sure you make them the opposite and you also make them the reciprocal. The reciprocal just means like you're going to flip that fraction. So right here I have, if I had three different equations and I simply ask you which lines are parallel and which ones are perpendicular, notice this is y equals mx plus b. The key here is you got to find out the slope. Look at the slope of them. And the way to look at the slope is to put them into y equals mx plus b. This one, a is already in y equals mx plus b, and the slope is 2, or 2/1. Now this is in slope intercept. This right here is in standard form. And so to find this in standard, what we're going to do is take this and solve for y equals mx plus b. Notice this also has slope 2. So m is 2. So I know A and B are parallel. Remember, parallel lines have the same slope. Now, letter C, I want you to notice that this is in point slope form. And again, to find the slope, we know the slope is right there. We don't have to put this in y equals mx plus b because it's in point slope form. So here the slope is -1/2. I mean, if you wanted to put it in slope intercept, then you can use the distributive property much like what we did last time. So this is m equals -1/2. Well, we know that this slope is 2, this slope is 2, and this is the opposite reciprocal. So C, letter C, is perpendicular to A and B. So that's what we would write. C is perpendicular to lines A and B. All right, because it's opposite reciprocal. Parallel lines have the same slope, and perpendicular lines have opposite reciprocals. And then one last problem. Write an equation of a line that passes through a point. This is very similar to the last one that we did, but this is perpendicular. So we're going to use point slope form. And the point is 1/7. So we know this is x minus 1, and this is y minus 7. So the question is, what do we use for the slope? Again, you got to pay attention to this. If it said parallel, then we would use the exact same slope as that line. But it doesn't say parallel, it says perpendicular. And perpendicular means opposite reciprocal. So this was negative, so we're going to put a positive number there. And the reciprocal of 1/4 is 4/1, or just plain 4. So this is point slope form. And again, to solve this, to put it in y equals mx plus b, so we're going to use the distributive property. So that's in y equals mx plus b. And this line, if we graphed both of those lines, they would be perpendicular to each other. We can graph the calculator or we can graph it on a piece of graph paper, but they would be perpendicular to each other. And that's parallel and perpendicular lines.